So a very warm good morning to all my dear students. So today we are going to learn one new important concept, that is called concept of atomicity. So hope you remember we have learned mole concept in terms of atoms, mole concept in terms of molecules or a compound, then mole concept in terms of electrons, protons and neutrons, then mole concept in terms of ions. Okay, so until now if you analyze, you will get a analysis like that. Means if atoms are taken, okay, you will calculate the number of moles of atoms, correct? If atoms are given, then you will calculate the number of moles of atoms or mass of atom, like that. And if a molecule or a compound is given, then you will if a molecule or a compound is given, then also you will calculate what? The number of molecules, the number of moles of molecules, mass, number of gram molecules, like that. And now I am going to explain a concept where the given stuff will be a molecule and you will be asked to calculate the number of atoms. Until now we were learning like if atoms are given, we will be calculating the number of atoms or converting into number of moles of atoms, like that. Or it will be like if molecules are given or a compound is given, then we will be calculating the number of moles of molecules or mass of molecules, or it will be volume, like that we were learning, correct? You remember. Now a new concept where you can say number of molecules, or they will be giving you a number of molecules either, or they can give mass of molecules, or they can give volume of molecules. Then from that they will be asking you to calculate the number of atoms. Understood? So that's why I have given the question, how to calculate the number of atoms if a particular number of molecule or a compound is given. That means from the molecule or a compound, how to calculate the number of atoms. Here is where the concept of atomicity is applied. Okay, so I will tell the strategy how to do that, then please follow it as such, then it will become helpful for you. Okay, so here the concept is, so first of all I will tell what is atomicity. So atomicity stands for the number of atoms present in a single molecule or a compound. The number of atoms present in a single molecule or a compound. So we will see some examples, then it becomes very easy for you to understand. So I am rubbing this question, so I can say the answer for this is the concept of atomicity needs to be applied, correct? The concept of atomicity needs to be applied. So we will see what is atomicity in detail, and also we will see how to deal questions of that nature. Okay. Okay, so I am taking some standard, so I can say, so what is the atomicity I have defined for you? Tell me. So atomicity can be defined as, it is defined as the number of atoms. It is defined as the number of atoms present in a single molecule or compound. It is defined as the number of atoms present in a single molecule or compound. Now we will see some examples. Now if I am taking O2, you know that it is an O2 molecule. Now can you tell me what is the atomicity of O2 molecule? I can say one O2 molecule is made up of 2 atoms of oxygen. So its atomicity is Now similarly, if I am taking O3, now can you tell me, it means O3 is ozone. So what is its atomicity? So I can say its atomicity is 3. Now we will take some mixed example. Calcium carbonate. So it's a compound made up of different atoms. Then if I am going to take the atomicity, then the question will come like atomicity of which atom? So I can write it as atomicity of calcium maybe. So atomicity of calcium, tell me in one compound, in one molecule, how many calcium is there? There is only one. So calcium is 1. Now if it is carbon, suppose in exam they are asking carbon, then its atomicity, we know that there is only 1. Then also answer is 1. Suppose they are asking for oxygen in calcium carbonate, then its atomicity will become 3. Understood? So this is the way we need to calculate atomicity. So I hope you understood the concept of atomicity. Now we will see how to apply this concept in the above scenario. That means how to calculate the number of atoms if molecules are given. So that I will explain. Please listen to that. Very easy. Okay. Okay. Now just I am explaining the concept. So I can say what is given. We will go from there. The questionnaire can give different things. So given can be either what they can give. So we know that they will be giving molecules and asking you to calculate the number of atoms. So given can be number of moles of molecules. Correct? They can give this, right? They can give you 5 moles of oxygen molecules. They can give this, or what they can give, tell me what are the other possibilities. They can give the number of molecules as such. They can say Avogadro number or like that. So number of molecules they can give, or what they can give? They can give molecular mass. It may not be molecular mass, it can be any mass. They can give any mass. Any mass of the molecule, any mass of the molecule in grams. They can give any mass of the molecule in grams, or what they can give? They can give the volume occupied by the or they can give the volume occupied the molecule. And what is the last possibility? It can be number of gram molecules they can give. Correct? So these are the different ways by which the questionnaire can represent the molecules. So we will see it in one shot. Okay. So they can give either directly the number of gram molecules, or number of moles of molecules, or number of molecules, or any mass of the molecule in grams, or volume occupied the molecule at STP. That is very important, otherwise there is no meaning. So at STP, I will mention that. At STP. So they can give any of this. So what is your strategy? From this you need to calculate the number of atoms. So I am telling what should be your strategy is whatever things they give. First thing you need to do is, if it is number of gram molecules, what you need to do? Convert that to always number of molecules first. First identify how many molecules, how many number of molecules are there. So I can say convert to number of molecules. And suppose if they are giving number of moles of molecules, then also the same is the strategy. Follow the same thing. that is convert to number of molecules. If it is they are giving any mass of the molecule in grams, then also convert that to number of molecules. Okay, now please don't ask me, sir, how to convert. I hope you are remembering. If they are giving number of number of moles of molecules, how to convert it into number of molecules, because we know the basic relationship between number of moles of molecules and number of molecules. One mole of a particular molecule will have how many number of molecules? Avogadro number of molecules. From that I can get the number of molecules. So number of gram molecules, and with the number of molecules I know the relation, and from the mass of the gram of the molecule, that between that and number of molecules also I know the relation. If you are not remembering that, please listen to my video mole concept in terms of molecules. There I am explaining if one is given and how to convert it to the other. So do that. Now here also I told, if mass of the molecule in grams is given, convert that to number of molecules. And similarly, if volume of the molecule is given, that also you should convert it to number of molecules. So the concept is very simple. They can give 1, 2, 3, 4, 5, any of the 5. So if directly they are giving number of molecules, you don't want to do, it's very easy. So if they are giving any other terms other than the number of molecules, convert that to number of molecules first. Okay. So first step is converting it into number of molecules. Okay. Once you know the number of molecules, stop there. First you calculate that. And next what you need to do? Next you need to calculate the atomicity of that molecule. What you need to do? Atomicity of that molecule or a compound. So suppose for example, if they are giving compound and they are asking you with respect to particular atom, you want to calculate the atomicity of that particular atom. So this is step number 1, converting it into number of molecules. Okay, I hope you understood. So I am just now rubbing it and writing it in terms of steps so that it is easy for you to remember. Okay, so step number 1, convert to number of molecules. Okay, now what should be the step number 2? Step number 2 is calculate the atomicity of that particular atom mentioned in the question. Calculate the atomicity of that particular atom mentioned in the question. Okay, mentioned in the question. Now once you know the number of molecules and atomicity, then how to calculate the number of atoms? I know number of molecules, correct? How many molecules are there? And I now also know what are the number of atoms present in one molecule. That is called atomicity, correct? So how many molecules also I know. So how much will be the total number of atoms? Total number of molecules multiplied by what? Atomicity. So the step 3 is so total number of that particular atom is equal to number of molecules multiplied by atomicity. Okay, I will tell a good example to understand it more. So this is the actual steps you need to follow. Understood? So now I will give an example. With that it will become easy for you to understand. Okay, so most of the time when we say all these things in steps like this, students will have some idea that at the end of the day they want to do calculate number of molecules and it should be multiplied by atomicity of that particular atom. This is what they will understand, but they won't get the complete picture. So for that I will take a genuine example. With that you will be able to correlate this. Okay, so I am rubbing this. So it is very easy only, so don't worry about it. But I can say this is the most repeated type of question, because here you need to apply the concept of atomicity. So that's why they used to ask this question very regularly. So very important topic with respect to entrance. So the simple example I am taking here is, everybody might be knowing a chocolate named Perk. Okay, so just I am drawing that for your understanding. Okay, so this is my Perk actually. So it's a bigger Perk. Okay, so you know what is this Perk is all about. You might have eaten this sweet or chocolate many a times. Now the advantage of buying a 10 rupee Perk, okay, I will say it's a 10 rupees Perk. Okay, so 10 rupee Perk is, if you buy a 10 rupee Perk, how many people can eat it? You may say, sir, I can eat any number of Perks, correct only. But minimum speaking, I can say 2 people can eat. Why? Because the reason for that is, in the Perk there is an arrangement like this. There is one chocolate here, clear demarcation, and there is another chocolate here. Correct? Hope you remember this, or when you, if you have eaten. So that means you need to compare now one Perk with the molecule. So Perk as a whole is my molecule here, and inside the molecule we know atoms are present. So now if you see, one molecule of Perk has how many atoms, or how many chocolates inside that? 2 bars can be seen. So I can say, if you consider it as a molecule, one molecule has how many atoms? 2 atoms are there. Correct. So the atomicity of the Perk is, okay, it is 2. Understood. Now the question here is very simple, and if there are 10 people are there, if there are 10 people are there, so as part of cost cutting, how many Perks, okay, you can say certain Perk can be bought. If you have enough money, you can buy it, no issues. Now think like a situation where there is no enough money is present. So tell me, what is the minimum number of Perks we need to buy? You know that only 5 Perks needs to be bought. 5 Perks, because inner to your mind you know that each Perk has 2 pieces. So I will open one Perk and give one piece to one person. So 5 Perks means it will give me what actually? 10 chocolates. Now you correlate this with our concept actually. Now they are asking you, one of the person is asking you, sir, please tell me how many chocolates are present in 5 Perks. Okay, one of the person is asking this question. Now it is same as our concept or question. Now given stuff is a molecule and they are asking you what? The atoms inside. Correct. 5 Perks they are given, or otherwise we can directly say, sir, 5 Perk means 5 chocolate. Is that correct? No, because here we refer chocolates means minimum eatable stuff. That is, I know that. So what should I do? First calculate the number of molecules or the number of Perks. So in this question it is clearly mentioned present in 5 Perks. So I know the number of Perks is equal to 5. Correct. And so this is similar to the number of molecules. This I have calculated, or it is directly given. Okay. And next I know the atomicity of the Perk. Atomicity means, now okay, here I am saying one Perk has how many chocolate? I can say one Perk has 2 chocolate. So that means what? Atomicity of the Perk is 2. Now tell me how many chocolates are there? Totally how many chocolates? So total number of chocolates. How can you calculate? You itself tell me. How to calculate? I know how many perks are there? 5. In each perk, how many chocolates are there? 2. So 5 into 2, I can say 10. So here actually what we have done, 5 is number of perks. That means the number of molecules multiplied by what? Number of chocolates in each one, that is atomicity. So 5 into 2, 10. So this is a simple example you can remember to learn the concept of atomicity. So in atomicity or the molecule concept, the molecule they will be giving. So here in the question they have directly given 5 perk. Suppose, as I told you, it cannot be directly they will be giving 5 perks. Instead they say 100 gram of perk mass is given. Then a question what you need to do? You need to convert this mass to corresponding number of perks. And suppose you know that 10 gram, in the packet it is written 10 gram is per perk. That is this whole stuff is 10 gram. You know, it is written. So now tell me 100 gram means can be divided by 10 gram to get the number of perks. So you know it is 10 perk. Understood? So first what you are calculating anyway? You are first calculating anyway the number of perks. That is what? The number of molecules. That is what initially I have told. Whatever they can give mass, number of moles, number of gram molecules or volume, whatever be it, convert that to number of molecules first. Here they can give the mass. Okay, only in the case of perk there can only be mass. So mass is given. I have converted that into number of perks. That is number of molecules. Then again do calculate the atomicity. That means for one perk how many are there? Similar to that, calculate the atomicity of that particular molecule. Then multiply these two to get the total number of atoms. In chemistry here, total number of chocolates. So I hope with this example you might have got a fair idea what is this concept all about. So next we will start doing some questions. With that you will get a complete clear picture. Okay. So listen here, now read the question. Calculate the number of atoms of oxygen present in 88 gram of carbon dioxide. So this is the question. Now if you see this question, analyze it. They are asking you the number of atoms, okay, but whether they have given atoms? No, they have given a molecule, not a molecule, compound. Molecule means it should be of same type of atoms. Compound means it is made up of different types of atoms. So they have given a compound, they have given the mass, and they are asking you the number of atoms. Okay, so tell me, mass is given and asking you to calculate the number of atoms. So what you are expected to do? Again you need to apply the concept of atomicity here. So what is the first step to be done? First to calculate the number of molecules of carbon dioxide. Here mass is given. From this you need to calculate the number of molecules of carbon dioxide. So which and all things to be related? Mass to be related with the number of molecules. So we know our basic concept. Mass means I can take the molecular mass in grams of carbon dioxide, that is 44 gram, correct, carbon 12, oxygen 16 into 2, 32 plus 12, 44. So that is the molecular mass in grams, correct. So I will write like that for your understanding. So molecular mass in grams. Here it is carbon dioxide, so that is 44 gram. So tell me, as per our concept, this will be equal to, or this is the mass of how many number of molecules? We have learned in our initial classes 6.022 into 10 power 23 CO2 molecules. Okay, hope you remember. So why I used this formula? Because I want to calculate number of molecules. That's why I have taken this. And what is given here? Molecular mass, or mass is given. So I have taken this formula. So from this I will find the number of molecules of carbon dioxide. And 44 gram we know. And how much is given here? 88 gram. So I need to know in 88 gram how many CO2 molecules are there. So tell me how to convert 44 to 88. You should multiply by 2. So here also then you need to multiply by 2. So this will become 12 into 10 power 23 CO2 molecules. Okay. So first step is calculating the number of CO2 molecules. I got the answer 12 into 10 power 23 CO2 molecules. So this I will rub now. So right now you got the answer. Now, not the complete answer. Number of CO2 molecules present in 88 gram of CO2. So you got it. That is 12 into 10 power 23. Correct. Now what is the next step? You calculated number of molecules. We need to calculate the atomicity of which atom. They have asked in the question. They have asked in the question oxygen. So next is atomicity of oxygen. Atomicity of oxygen in CO2. Now tell me, if you take a single molecule of CO2, how many oxygen atoms are present? 2 oxygen atoms are present. So my atomicity of oxygen is equal to what? 2. So I got these 2. Now what is the total number of atoms of oxygen? So total number of atoms of oxygen. Total number of atoms of oxygen is equal to what? I know these are the total number of molecules, and each molecule has how many oxygen atom? 2 atom. So what should be done? 2 plus 2 plus 2 plus, like that you can do. That will take a huge amount of time. Or you can say this many number of molecules are there and each molecule has 2 atoms. So 12 into 10 power 23 into 2, or the number of molecules into atomicity. So that is 2 into 12, that is 24 into 10 power 23. What atom? Oxygen atoms. Understood? So this is the basic way you are doing the calculations. And please remember here, now here they are asking to calculate the number of atoms of oxygen. Sometimes in the exam they will be asking you to calculate the number of atoms of carbon here. In that case, what will be the atomicity of carbon in CO2? The value will be 1. Then 12 into 10 power 23 into 1, and my answer remains 12 into 10 power 23. That is 12 into 10 power 23 oxygen atoms are, and not oxygen atom, carbon atoms are there. And sometimes they will ask you, instead of a particular atom, instead they will say calculate the total number of atoms present in. Total number of atoms means they are asking you to calculate both carbon and oxygen. Then what you are expected to do? Find the atomicity of not a particular atomicity of each atom. That means atomicity of carbon you need to calculate. So that suppose if they are asking calculate the total number of atoms, means what you need to do? You need to calculate the atomicity of all the atoms present in that. So here carbon atomicity is 1, oxygen atomicity is 2, then you add the total atomicity, that is 2 plus 1 3, that is the total number of atoms present in one molecule. Then here 3 will come, that 3 should be multiplied with the number of molecules, 12 into 10 power 23. Then you will be able to calculate the total number of atoms present in 88 gram of carbon dioxide. So I hope you understood the concept. So we will do some more questions and then we will go to the next concept. Okay. Okay, now read the second question. It's almost same. I made only a single change. You can see here. Again, they calculate the number of atoms of oxygen that is present in 2Na of carbon dioxide. So what is the difference I made? Earlier in the question, okay, here also the molecule is given or compound is given and they are asking you to calculate the number of atoms. But in the previous question, the mass was given and I was asking you to calculate the number of atoms. So first step was identifying the number of molecules or number of molecules present in that given mass. But here you can see the number of molecules is directly given in the question. Oxygen present in 2Na. 2Na means 2 into 6.022 into 10 power 23 molecules or compounds of carbon dioxide. That means the number of molecules is directly given. Understood? So do you want to convert this into number of molecules again? There is no point in saying that. Correct. So this is a direct thing. So number of molecules is directly given means what is the next thing you need to do? Calculate the atomicity of the particular atom. Then do the multiplication. So I can say the number of molecules of carbon dioxide is equal to number of molecules of carbon dioxide is equal to 2Na, that is 2 into 6.022 into 10 power 23. So this is the number of molecules. And next is what? You need to find the atomicity of oxygen in CO2. So tell me that we already know it is 2. Now tell me what is the total number of atoms of oxygen then? Total number of atoms of oxygen, total number of atoms of oxygen in 2Na CO2 molecule is how much it will be? Number of molecules, that is 2 into 6.022 into 10 power 23 multiplied by atomicity into 2. So answer will be 6 into 2 12, 12 into 2 24, 24 into 10 power 23 oxygen atoms. Correct? So this is the way you need to do it. So I have generated the next possible question. That is, first possible question was mass was given, so converted that into number of molecules and then find the number of atoms. Now in the second possible question, number of molecules is directly given, so you are multiplying that into with the atomicity to get the number of atoms of that particular compound. Now what can be the third possibility? They can give you the number of moles, right? So you will generate the third question out of this. Okay, so the third question will be something like this. Okay, so I can say in 0.25 mole, okay, 0.25 moles of carbon dioxide, 0.25 moles of CO2. Okay, so tell me here what is the difference? Again, molecule is given and asking you to calculate the number of atoms, but here you can see the molecules is given in terms of moles. So what is my first step? Convert this number of moles into number of molecules. Once you know the number of molecules, what you need to do? Calculate the atomicity, multiply those two. So you need to convert moles into molecules. So we know that again our fundamental relationship between moles and molecules. What is that? 1 mole of that particular molecule. What is that? CO2. 1 mole of CO2 molecule will have how many number of molecules? We learned this 6.022 into 10 power 23 CO2 molecules. Correct? Now 1 mole, this is a fundamental step. So they are asking you in 0.25 moles. So given is 0.25 moles of CO2 molecule. So 0.25 is what they have given. So how to convert 1 into 0.25? You know that it should be multiplied by 1 by 4 because 1 by 4 is 0.25. So you will get 0.25 mole. So if you are doing that here, multiply here also with what? 1 by 4. So the answer will become 6 by 4. So 6 by 4 is nothing but 3 by 2. 3 by 2 is 1.5 into 10 power 23 CO2 molecules. Okay. So right now I know 0.25 moles of CO2 molecule is equivalent to how many CO2 molecules? 1.5 into 10 power 23 CO2 molecules. So I have calculated the number of molecules. Correct. So I can rub this. So now I know the number of CO2 molecules present in 0.25 moles of CO2 is equal to what? Just now we calculated, it is 1.5 into 10 power 23. Okay, 1.5 into 10 power 23. Now next, what is the step? Calculating the atomicity. So the question they are asking you the oxygen only. So the atomicity of oxygen we already calculated many a times. Atomicity of oxygen in CO2 is equal to 12. Now tell me the total number of oxygen atoms. So total number of oxygen atoms in 0.25 mole of CO2 is equal to what? Number of molecules 1.5 into 10 power 23 multiplied by atomicity, that is 2. So 1.5 into 2 is 3 into 10 power 23 oxygen atoms. Okay, 3 into 10 power 23 oxygen atoms. So this is the way we can do it. Understood? So again I am telling the same thing, whatever they are giving here, number of molecules are directly given, don't do anything. Otherwise any other things are given, convert that into number of molecules. Then what you need to do, take the atomicity of the particular atom, then multiply those two to get the total number of that particular atoms. Okay, so we will make a change in the next question. Instead of oxygen we will do carbon next time. Okay, so the next question, we will go to the next question. Listen. So calculate the number of atoms of carbon. I will say it here, carbon present in. Okay, now I have given you mass, number of molecules I have given you, number of moles I have given you. What is the next thing? I can say 0.5 gram molecule. Okay, the next term, gram molecule of CO2. Okay, so tell me again, in this question they have given you number of gram molecules, that should be converted to number of molecules. So again I know my fundamental relationship, 1 gram molecule of what is the compound here, CO2, is equivalent to how many number of molecules? We learned this in our fundamental class. We know it has 6.022 into 10 power 23 CO2 molecules. Correct. Now they have given what? 0.5 gram molecule. So 0.5 gram molecule of CO2. So tell me, how can you convert 1 to 0.5? Multiplying by half. So here also you can say, do the same thing on the RHS, multiplying by half. So this will become 3 into 10 power 23 CO2 molecules. 3 into 10 power 23 CO2 molecules. So I right now calculated the number of molecules present in 0.5 gram molecule of carbon dioxide. Okay, so this we will rub. So right now I know the number of molecules, number of CO2 molecules present in 0.5 gram molecule of carbon dioxide. Just now we have calculated, the answer is 3 into 10 power 23. Now again the atomicity we need to calculate, but in the question right now they have asked the number of atoms of carbon in CO2. So atomicity of carbon in CO2. Tell me, what is that? How many carbon atoms are there in one molecule of CO2? It is 1. So it is 1. Now in one molecule it is 1. Now they are asking you to calculate in 0.5 gram molecule. So what is our step? Multiply the number of molecules with the atomicity. So total number of carbon atoms in 0.5 gram molecule of CO2 is equal to what? I can say 3 into 10 power 23 multiplied by this 1. So same answer you will get. So I can say 3 into 10 power 23 carbon atoms. Okay, 3 into 10 power 23 carbon atoms. So I hope this also you understood. Now we will go to the last one. Now given was initially it was given what? The mass was given, then the number of molecules was directly given, then number of moles was given, and number of gram molecules was given. What is the fifth possibility? They can give the volume. Correct. Then you need to calculate the number of atoms. So if volume is given, surely they should mention at what temperature and pressure it is done. So that they will mention in the question. So I am rearranging the question again. So but here I am again changing the question in such a way that calculate the total number of atoms. Okay, we didn't do it like this, right? So calculate the total number of atoms present in, okay, number of atoms present in let me say present in some 44.8 liter of carbon dioxide at STP. 44.8 liter of carbon dioxide at STP. So this is the question. So here they are asking you the total number of atoms. So what you need to do, atomicity of not a particular atom, you need to calculate the atomicity of each atom and you need to add that to get the total number of atoms of present in a one molecule. Okay, so we will first do that. So this might be the last question present in this category for your understanding. So tell me, so calculate the total number of atoms present in 44.8 liter of carbon dioxide at STP. Again number of atoms being asked and given is a molecule or a compound. So first what you need to do, you need to convert this volume, and you know that it is at STP. So this volume to what you need to convert this to number of molecules. And I know my standard relationship, that is 6.022 into 10 power 23 CO2 molecules at STP will occupy how much volume? We know that it is 22.4 liter. This is my fundamental concept. And we know that they are asking you, we need to calculate the number of molecules at STP present in how much liters? 44.8 liters. So here also I will mention at STP, very, very important. So in 44.8 liters at STP. So tell me how to convert 22.4 liter to 44.8. You know that it should be multiplied by 2. Okay, so when you multiply by 2 on RHS, do it same thing on the LHS, multiplying by 2. So this will become what? 12 into 10 power 23 CO2 molecules at STP. Okay. So right now I have calculated the number of CO2 molecules present in 44.8 liters at STP. What is that? 12 into 10 power 23. So I can rub this. So right now I know the number of molecules, so I will write it as the number of CO2 molecules present in 44.8 liters at STP. How much it was? Just now we calculated. It was 12 into 10 power 23. Correct. So it was 12 into 10 power 23. Now what you need to do? They are asking you the total number of atoms. So I will say the atomicity, or I will define it like total atomicity. So it will become easy for you to understand. So total atomicity, which will be equal to what? Atomicity of carbon plus atomicity of oxygen. So atomicity of carbon is 1 and the atomicity of oxygen is 2. So the total atomicity is 3. Now last step will be total number of atoms. Total number of atoms present in 44.8 liter of CO2 at STP. It will be equal to what? Number of molecules 12 into 10 power 23 multiplied by total atomicity. Why I am taking total atomicity? Because they are asking you the total number of atoms. So 12 into 10 power 23 into 3, that is 36 into 10 power 23 atoms. I cannot say any particular atom because it is total number of atoms. So the atoms here there are multiple types of atoms are there. So I can say 36 into 10 power 23 atoms. Understood? So I hope with this you got a fair idea regarding the concept of atomicity and everything. So in the next class we will be learning the concept of empirical formula and molecular formula. Okay, we will learn that and we will proceed. Okay, so thank you for your patient listening. Have a nice day ahead.